Hello students, welcome. On our previous classes, we were dealing with the chemistry of metals. So today, we'll be proceeding to topic 6 and the name of the topic is Organic Chemistry 2. We are going to start with lesson 1. In this lesson, we are going to do number 1, the introduction of organic chemistry, number 2, nomenclature of alkanols, number 3, classification of alkanols, number 4, isomerism in alkanols, number 5, we'll be concluding with 4 extended questions. So kindly stay with us until the end of the video. So to start with the introduction of organic chemistry, we are saying what is organic chemistry? Organic chemistry is the study of carbon compounds excluding the oxides, carbonates, and hydrogen carbonates. Next, we are saying in organic chemistry 1, alkenes, and alkynes were studied. So in this chapter, organic chemistry 2, alkanols, alkanoic acid, detergents, and polymers will be discussed in details. So we are going to start with the first one, that is alkanols. So let's start number 1, alkanols. So alkanols are also known as alcohols. So we are saying alkanols are organic compounds that contain a hydroxyl group, that is OH group, as their functional group. And next we are saying the functional group determines the chemical properties of the alkanols. Remember, when we are dealing with the hydrocarbons, the 3 classes of hydrocarbons, those were alkanes, alkenes, and alkynes. We said alkanes have no functional group. But when we're talking about alkene, for example, ethene, we were having double bond as its functional group or as their functional group. Then when we're talking about alkynes, like for example, ethane, we were having triple bond as their functional group. So when we're talking about alkanols, we are having hydroxyl group as their functional group. And we are saying the functional group determines the chemical property of the alkanols. So next we are saying alkanols are commonly called alcohols, and we are saying they are saturated organic compounds. Remember, the 3 hydrocarbons, we were having alkanes to be saturated hydrocarbon, and we said alkenes and alkynes are unsaturated hydrocarbons. So let us proceed to the next part of our class, that is nomenclature of alkanols, that is naming of alkanols. So we're saying alkanols are named by replacing the E of the corresponding alkene with the suffix OL. Methane. So if you check the word methane, the name methane, it's ending with E. So for us to make this alkane to alkanol, we remove the E and we will replace with the suffix of OL. So what we are going to get will be methanol. So if we're talking about ethane, we said ethanol in alkanol. If you are talking about propane, we'll make it propanol. So next we are saying alkanols have a general formula of CnH2n plus 1 OH, where N is the number of carbon atoms. That means it can be 1, 2, 3, 4, 5, 6, 7 like that. Or we can write ROH, where R represents the alkyl group. And we're saying the simplest alkanol is methanol, where N is equal to 1, and this formula is CH3OH. Remember, when we are talking about alkenes, we say the general formula for alkane was CnH2n plus 2. When we are talking about alkenes, we say the general formula is CnH2n. When we are talking about alkynes, we say the general formula is CnH2n minus 2. When we are talking about alkanols, we say the general formula is CnH2n plus 1 OH. What happened? Here what happened is that the general formula for alkene, the one for alkene, that is CnH2n plus 2, where we were having the number of hydrogen atoms, we have removed 1 hydrogen and we have replaced it with the hydroxyl group. So this hydroxyl group will become the functional group for alkanols. So next we are saying alkanols may be considered as derivative of water in which one of the hydrogen atoms in the water molecule is substituted by an alkyl group. For example, let's start Roman 1. Methanol. Methanol is written CH3OH is obtained by replacing one hydrogen atom by a methyl group, that is a CH3. So how is it done? How do we write first of all water? Water is written H2O. What do we mean by this? We're having one oxygen bonding to two hydrogen. That's the structure of water. So here we are having methanol. And methanol, for example, when we make it in alkyl group, we are going to have methyl. That's what we're going to have there. So if we're having methyl, what are we going to do? We are going to substitute one hydrogen with a methyl group, which is a CH3 group. So when we join them, what we are going to get is CH3OH, which is the formula for methanol. So Roman 2, let's see ethanol. Ethanol can be written like this or C2H5OH. That's the other way that we can write. Is obtained by replacing one hydrogen atom by an ethyl group. So, as usual, let's see the structure of water. The structure of water look like this. So, if we are talking about ethanol, we talk about ethyl as the alkyl group. So, how do you write ethyl? Ethane is written C2H6. So for you to write alkyl, you remove one hydrogen from ethane. So what you're going to get is C2H5 as the alkyl group. So what we are going to do is we substitute one hydrogen with this alkyl group, that's ethyl group. So we're going to put here C2H5. So if we combine C2H5 with this OH, what we are going to get will be C2H5OH. So next we are told note, when naming alkanols with 3 or more carbon atoms, the position of the functional group, that is the OH group, must be shown in the name. For example, if I'm talking about the third member of alkanol series, I will not say propanol, I say propan-1-ol. We have to at least show the number to which the functional group belongs. So that means if you are talking about one with 4 carbon atoms, you say butan-1-ol or butan-2-ol. So next we are told the table below shows the names, the molecular formula, and the structures of the first 5 members of the alkanol series. So here we have the names, here we are having the molecular formula, the condensed structural formula, and also the structural formula, that's the open structural formula for the alkanol series. So let's start with the names. So the first member is called methanol, and the molecular formula will be CH3OH. So what have we said about molecular formula? We said a molecular formula shows the elements present in a compound and the proportions of their atoms in the compounds. So you have to know that is what molecular formula shows. What about the structural formula? Be it condensed or open structural formula. We are told a structural formula shows how the atoms of the different elements are arranged in the compound. And we are told the structural formula for hydrocarbon or organic compound can be represented as open or condensed structural formula. So we can write molecular formula of methanol to be CH4O like that. The reason why we are writing it like this is that we said molecular formula will show the elements present in the compound and the proportion of the atoms in the compound. That means we have 1 carbon, 4 hydrogen, and also 1 oxygen. So instead of us writing CH3OH, we can still write CH4O as the molecular formula for methanol. Next, let's go and see the open structural formula. then we will come back for condensed structural formula. So how many carbon do we have in methanol? One carbon, because it's having the prefix meth or methan, which stands for one carbon atom. So first of all, we write one carbon, and we said each carbon has a valency of 4, so it's going to have 4 bonds. Then next, how many hydrogen do you have? You have hydrogen, so we write 1, 2, 3, 4. Then check, we are having one oxygen, so that means we are going to put one hydrogen with oxygen to make the OH, which is the functional group. So this is how we write the open structural formula for methanol. So next, what we are supposed to do is that the condensed structural formula for methanol. So check each carbon, how many hydrogen is it attached to? So here we have C, then we are having H3, that is it. Then we are having the functional group, that is the OH group. So next, we want to proceed to the second member, that is ethanol. Ethanol is written C2H5OH. This is when we show the functional group. If you don't want to show the functional group, the molecular formula can be written C2H6O. That's also the molecular formula for ethanol. So let's do the open structural formula. So first of all, we have to see how many carbon we have. We have 2 carbon. So these are the 2 carbon. And in each carbon, it's having 4 bonds. That's the 4 bond. These are the carbon, 1, 2, 3, 4 bonds. So we say, how many hydrogen do we have? We have 5. 1, 2, 3, 4, 5. That means we are going to end with the functional group. That is the OH group. So next, we are going to go to propanol, which we have said when we are naming alkanols with more than 3 or 3 carbon atoms, the functional group, the position of the OH must be shown. So we have to say propan 1-ol. That will be the name. So to write the molecular formula, we can write C3H7OH to show the functional group. If you don't want to show the functional group, what we can write C3H8O. That's what we can write. So next, let's see the open structural formula. The way you see, we have 3 carbon, 1, 2, 3. Then if we check here, we have 7 hydrogen. That's 1, 2, 3, 4, 5, 6, 7. Then the functional group will be placed there. To name this compound, we are going to have propan 1-ol. Then next, we are going to go to butan 1-ol. Then the molecular formula will be C4H9OH. If you don't want to show the functional group, you can write C4H10O. So the open structural formula will be, we are supposed to have 4 carbon, the way you see. Then we are supposed to have 9 hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we are going to end with the functional group. That's the OH group. Let's come for the condensed structural formula. We can ask ourselves the first carbon, how many hydrogen is it attached to? That's 3. So we're having CH3. What about the second carbon? It's attached to 2 hydrogen. That's CH2. What about the third carbon? It's attached to 2 hydrogen. That is what we're going to have. The fourth carbon is attached to 2 hydrogen. So that's the 2 hydrogen. Then we're ending with the functional group like that. So we can simplify this condensed structural formula because we have 3 CH2. So what we can do is we can write the CH3, then we take one CH2, we put bracket, then we ask how many CH2 do we have? That's 3. We put the 3 down, then we end with the functional group. So if you write it like this, the condensed structural formula, you are very correct. If you write it like this, you're also very correct. So let's proceed to pentan 1-ol. This is pentan-1-ol. The molecular formula will be C5H11OH if you want to show the functional group. If you don't want to show the functional group, it will be C5H12O. So let's see the open structural formulas. So we are having 5 carbon, 1, 2, 3, 4, 5. So that means each carbon is going to have 4 bonds. So you have to know that. Then what we're supposed to know is that how many hydrogen do you have in pentanol? That is 11 when we show the functional group. So you put 11 hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 like that. Then we end with the functional group. That's the OH group. Next, we want to show or we want to represent this open structural formula into condensed structural formula. Or we want to write this pentanol into condensed structural formula. What we are supposed to know is that how many carbon do we have? We have 5 carbon. The first carbon will be having 3 hydrogen. The rest, the other 4 carbon are going to have two hydrogen. Then we are going to conclude with the functional group. So the other way we can write is that we can write the CH3, then we have many CH2, we can put 1 in bracket, then we count the number of CH2 we have. That is 4. We put the 4 down, we conclude with the OH, which is the functional group for the alkanol series. So next, let's go naming and drawing alkanols. So examples, we are going to start with the number 1. We are to name the following compounds. Part A, we are given this compound. So for us to name, we are going to use the rules. And the naming of alkenes and alkynes is the way we are going to name alkanols. The rules are this one and the same. So first of all, I have to count the longest chain so that I get the parent name. So I'm having 1, 2, 3, 4, 5. So that means the prefix for alkanol that stands for carbon number 5 is called pentan. It's called pentan. So we're going to have pentan there. Then next we are supposed to ask ourselves which carbon is attached to the functional group. The functional group is OH. So we start numbering from right to left. So we're going to have 1. If we count from left to right, it becomes 1, 2, 3, 4, 5. So that means 1 and 5, 1 is better because we are supposed to write the smallest number. So that we are going to have 1, then we write the suffix for alkanol, which is ol. So the name will be bentan 1-ol. So part B, we're having this compound, and here we first of all count the number of carbon atoms. We're having 1, 2, 3. So we have to say propan is our prefix. So next, I have to know which carbon atom is attached to the functional group. So I have to number from both sides. 1, 2, 3. Then here 1, 2, 3. So if I see, I have 2 functional groups. One is here OH, the other one is there. So that means here we're having carbon number 1. Here we have carbon number 3. So I use that route. That is from left going to the right. So that means one functional group is in carbon number 1. I have to say 1, comma. The other functional group is in carbon number 2. So I have to say 2. Then there are 2 functional groups. I have to say di. Then I will end with ol, which is the suffix for alkanol series. So we go but C. But C, we are given this compound. So first of all, I have to count the number of carbon atoms in the longest chain. So it's 1, 2, 3, 4. Remember, this is not carbon in the longest chain. This is an attachment because it's attached to this carbon. Yeah, it's attached to this carbon. You have to know that. So if you're having 4 carbon, the prefix will be butan. Yes. The next, I have to ask myself, where is the functional group attached to? It's attached to carbon number 1 when we count from right to left. So let's proceed. We write 2, we write 3, we write 4. Then that means what I'm going to write is 1 or. Next, I have to ask myself, do you have an attachment or a branch? Yes, we have a methyl branch. So which carbon atom is it attached to? That's carbon number 3. So we say 3 methyl butan 1-ol will be the name of that compound. We proceed to D. So D, this is the way it is written. Yeah. First of all, we count the carbon atoms in the longest chain. That's 1, 2, 3, 4. Remember, this is not a carbon in the longest chain. This is an attachment. So the parent name is going to have the prefix for butan. The next, let's know where is the functional group. Which carbon atom is in functional group? So 2, 3, 4. So the functional group is here. So it's in carbon number 2. So we're going to have butan 2-ol. Then check, I have an attachment of CH3, which is in carbon number 3. So I have to write 3 methyl butan 2-ol. Then part E. Part E here, we have the longest chain to have 1, 2, 3, 4, 5 carbon atoms. So we have to say pentan. So next, which carbon is attached to the functional group? So I have to write from 1, 2, 3, 4, 5, because the functional group is here. So that means this is where it is near. So it's placed in carbon number 2. Carbon number 2 is there. So we have to say 2 ol. Then do you have an attachment? Yes, I have here Br. That's bromine. So which carbon atom is it attached to? 5. So I'm going to have 5 bromobentan 2 ol. That's how we name alkanol compounds. It's very simple. It's just how we name alkenes, alkynes, and alkenes. So question 2. Question 2, we are told draw the structural formula for each of the following compounds. So when you are told draw the structures or the structural formula, you can decide to draw open or you can do condense. You still get the marks. So I'm going to start part A. We are told 2,3-dimethyl pentan 2. First of all, let's let's know our parent name. It's having the word pentan. That means have 5 carbon atoms. 1, 2, 3, 4, 5. They show every carbon has 4 bonds. Okay, next. Which carbon atom is placed to the functional group? That's carbon number 2. So we can write 1, 2. So we can write the OH here or even here. So, do we have an attachment? Yes, we have 2 attachments of the same, that is methyl. The word dimethyl will tell us the 2 are of the same kind. That means they are in methyl group. So, one is in carbon number 2. Remember, even the functional group was in carbon number 2. So, that means when we have the OH, the CH3 will also be on the same carbon. The next, the third attachment will be in carbon number 3 because we are counting from here. Carbon number 1, carbon number 2, carbon number 3. So this is how we write the structural formula for this compound. The rest we are going to put hydrogen, hydrogen, hydrogen like that. So, but B, we are told 2,3-dichlorobutan 1 ol. So butan, that means having 4 carbon. So what we can write is, we can do it like this. So show all the bonds. The next, I have to know where is the functional group. It's carbon number 1. So I can even decide to put there. So next, do you have an attachment? Yes, I have 2 attachments of the same. That's chloro. So one is in carbon number 2. So this is carbon number 1, carbon number 2. So I can decide to put here or up there. Then the other one is in carbon number 3. So you can put here or up there. The rest you fill with hydrogen. The rest you fill with hydrogen. So what I've done here is the open structure for this compound. But what you can do is you can even draw condense. How? You write CH3 because you see C we are having H3. The next here is we have CH, then we have Cl. So you can put the Cl down or you can put bracket like that. Then the third carbon is having C with the chloro. That means 1 hydrogen, and we are having the function, the attachment here, chloro. You can put bracket or you leave it like that. Then you can write the 4th carbon is having 2 hydrogen with OH. You can write the compound like that in condensed structural formula. So next, let's proceed to classification of alkanols. And we are saying alkanols are classified as primary, secondary, and tertiary alkanols. So let's start with the first one, that's primary alkanols. So we're saying these are alkanols in which the functional group, that's the OH group, is attached to a terminal carbon atom. So we're saying examples of primary alkanols, they include this example. Here we're having butan 1 ol. When we check the structure, it's having 4 carbon atoms and the functional group is placed in carbon number 1 when we count from right to left, and it is placed in carbon number 4 when it's count from left to right. So that is a terminal carbon atoms. So it is either the first, yeah, for example here, or the last carbon. Second example is here. Here we're having boroban 1 ol. Check the carbon atoms are 3 and the functional group is placed in carbon number 1 when we count from left to right. So if we put the functional group in the terminal carbon atom, what's the terminal carbon atom? It's the first carbon or the last carbon. That's called a terminal carbon atom. Or a carbon with two hydrogen atoms. If the functional group is attached to a carbon with two hydrogen atoms, that alkanol will be regarded or will be named as primary alkanols. So you have to know. You can say to a terminal carbon atom, or the functional group is placed or is attached to carbon with two hydrogen atoms. With two hydrogen atoms. The way you see that is a primary alkanol. So number two, let's proceed to secondary alkanols. So we're saying these are alkanols in which the functional group, that's the OH group, is not attached to the terminal carbon atom. So that means it is attached in the middle carbon atoms. Examples of secondary alkanols include, we're having butan 2-ol. Check now, the first carbon is here and the last carbon is here. They have no functional group. So when we check the second carbon, when you count from right to left, it's having the functional group. So that means this structure, this compound will be for secondary alkanol. So the other way you can know is that the secondary alkanol will be an alkanol in which the carbon to which the functional group is attached to has attached to one hydrogen only. Second example, we're having propan 2-ol. So when you check, the functional group is placed in the middle carbon. It's not placed in the terminal carbon. So that means the functional group is attached to carbon with one hydrogen. Check, it's having one hydrogen. Even here, one hydrogen. So such structures of alkanol will be secondary alkanols. So number three, we're having tertiary alkanols. So we're saying these are alkanols in which the functional group, that's OH, is attached to a carbon atom with no hydrogen atom. There's no hydrogen atom in that carbon atom attached to the functional group. Examples of tertiary alkanols include, we're having these structures. So that means we're having the functional group in carbon number 2, and it is having an attachment or a branch. So that means there's no hydrogen in the carbon atom to which the functional group is attached to. So the name of this compound will be 2-methyl-butan 2-ol. So this is another example. We're having 2-methyl-propan 2-ol. So check here, this is the carbon to which the functional group is attached to. It has no hydrogen. That means it's having an attachment or methyl attachment. So let's proceed to isomerism in alkanols. And we say in alkanols also show isomerism. There are two types of isomerism shown by alkanols. These are, number one, positional isomerism. We're saying the position of the functional group, that's the OH, can change from one carbon to another in the molecule, leading to the formation of positional isomers. For example, we are going to do propanol, and this is the molecular formula for propanol. Remember we said isomers. What are isomers? We said isomers are compounds that have the same molecular formula, but they have different structural formulas. So the molecular formula is C3H7OH. So the first positional isomer of propanol will be propan 1-ol. So the second will be, the functional group will be placed in carbon number 2. So it will be propan 2-ol. So that means propanol has only two positional isomerism. That is propan 1-ol, propan 2-ol. If we try to put this functional group, that's OH, to this carbon, it will be propan 1-ol, because we'll be counting the number of carbon atoms from left to going to the right. So it is just the same as to this one. We are going to proceed to butanol, which it is molecular formula is C4H9OH, and the first one will be in carbon number 1. So this will be butan 1-ol. If we count the number of carbon atoms, 1, 2, 3, 4, that means the functional group is placed in carbon number 1 when we count from right to go to the left. So we take this functional group and we put it in carbon number 2, this side. That's what you see here. So to name this compound, it will be butane 2-ol. If we try to take this functional group to this carbon atom, it will be still butane 2-ol because we'll be counting from left going to the right. So it will be 1, 2, which we have written here, 2 butane 2-ol. Then we are going to have part C, that means pentanol. So it's written C5H11OH as this molecular formula when we show the OH. If you don't show the OH, the molecular formula for pentanol will be C5H12O. So we're having the first one to be placed in the first carbon, the functional group, that's pentan 1-ol. Count the number of carbon atoms, 1, 2, 3, 4, 5, and the functional group is placed in carbon number 1 when we count from right going to the left. So we take this functional group and we put it in carbon number 2 because we said when we are forming positional isomers, we change the position of the functional group from one carbon to another. So let's take the functional group from carbon number 1 to carbon number 2. So the name of the compound will be pentan 2-ol. Then we take from number 2, then we put to number 3. So we put it here. So if we count from here, it will be 1, 2, 3. The functional group is in carbon number 3. If we count from this other side, it will be 1, 2, 3 still. So that means we are going to have the name to be pentan 3-ol. So if we take from here and we put in this carbon atom, it will be pentan 2-ol. So next, number 2, we are having branching isomerism, and we're saying this occurs when a substituent group is attached to one of the carbon atoms in the longest chain containing the functional group, that is the OH group. The substituent group that we're talking about is an alkyl group. So let's see examples. Number 1, we are talking about butanol. So the molecular formula for butanol is C4H9OH when we show the functional group. If we don't show the functional group, it will be C4H10O. So the first one, we are going to have butan 1-ol, like that. The functional group is placed in carbon number 1. So the second, we are going to remove one carbon so that we remain with 3 carbon, 1, 2, 3. The functional group will still be placed in carbon number 1 like this. Then the fourth carbon, we are going to make it as an attachment. So we are going to put it in the middle carbon. So we can put up there CH3, or we can put H there, then we put CH3 in this side. So to name this compound, it will be 2 carbon number 1, carbon number 2, 2 methyl boroban 1-ol. That will be the 2 branching isomers of butanol. Then we go to pentanol. Its molecular formula is C5H11OH when we show the functional group. If we don't show the functional group, it will be C5H12O. So we start with the first one. So it is pentan 1-ol. Here we are making the functional group in carbon number 1. So next, what we are supposed to do is we remove one carbon so that we make that carbon as an attachment. So we are going to have with 4 carbon, 1, 2, 3, 4. The functional group will be still placed in carbon number 1. So it will be having butan 1-ol. So the attachment here, the CH3 will be placed in carbon number 2. So we're going to have 2 methyl butan 1-ol. So that means this structure and this structure, they have the same molecular formula, that is C5H11OH or C5H12O, but their structures are different. That's why they're having different names. So the third, what we are supposed to do is that we transfer this CH3, this attachment, to this carbon, that means carbon number 3, so that we have our name to be 3 methyl butan 1-ol. So what we have done is we have taken from here, then we put it here. So what does that mean? That means the molecular formula still remains the same, but it's only the structure which is different. Then next, what we are supposed to do is that if we try to take from CH3 from this carbon and we put to this carbon, it will be a long chain. We will go back to pentan 1-ol. So instead, what we are supposed to do is that we remove one carbon from this structure. So that we are going to remain with 3, 1, 2, 3 carbon. So that's 1, 2, 3. So the functional group will be still placed in carbon number 1. So we're going to have propan 1-ol. So for us to make it 5 carbon, we are remaining with 2 carbon. So we're going to put one methyl group here, another methyl group there. So when we check now, it's going to have 5 carbon. 1, 2, 3, 4, 5. That's C5. We are going to have 11 hydrogen. That's 1, 2, 3, 4, 5. Plus 3, 8, plus 3, 11. OH. That's the OH. So that means these are the 4 branching isomers of pentanol. You have to know that. Next, learners, we are going to proceed to the last part of our class. That's extended questions. So you said we are going to conclude with 4 extended questions. Kindly have a look at them. Learners, that's the end of our class. Thank you for watching.